Hi everyone! We are going to talk about how heat rigor works. Introducing our group members. Now, let's dive into our contents for this video. So, let's proceed to our first content, which is introduction and objectives. Shortening of sarcomers that occur at higher temperature is called heat shortening. Heat shortening regions lie at pH lower than 6.0 and temperature greater than 35 Celsius. Elevated temperature lead to rapid decline of pH due to glycolytic enzyme activity and faster glycolytic rates. For the meat quality, high rigor temperature can lead to toughening of meat, which reduce the tenderness of meat, and a high rigor temperature also promotes light scattering by generate structural alterations, which results the meat appear paler. The objectives of this study are to investigate the biochemical and physical changes of meat at high rigor temperature, to evaluate the muscle contraction of muscle tissue at high temperature, to compare the biochemical changes of heat rigor to rigor mortis, and to study the solutions for heat rigor meat. For the next content, we will show you how the analysis was done. The sample preparation began with setting up the water bath at 40 degrees Celsius. Next, the chicken was cut in half, and the chicken breasts were sliced for each left and right pectoralis. The chicken breasts were then divided into two categories, which were incubated for 1.5 and 3 hours. The samples were placed in sealed bags to prevent moisture loss during incubation. As for the pH analysis, 1 gram of the sample was weighed and homogenized with 5 milliliters of distilled water. The pH was then measured directly, and values were recorded. The analysis of color was measured at 3 points of the sample's surface using colorimeter. The results obtained were recorded. As for the water holding capacity analysis, 3 grams of the sample was weighed and placed in between 2 pieces of Whatman No. 1 filter papers. The filter papers with chicken samples were placed on a flat surface and covered with aluminum foil. The samples were pressed using 2 kilograms of load for 2 minutes. After that, the weight of the pressed samples were weighed. The same analysis pH, color, and WHC were repeated, using the sample that were cooked in the water bath at 40 degrees Celsius for 1.5 and 3 hours. The control also being analyzed again after 1.5 and 3 hours. Next, the data obtained will be discussed in the third section. First, the analysis of pH. From the table, it shows that the chicken breast pH value for both temperature increase after those hours. Based on the theory, the increase of heat will increase the glycolysis process, which increase the lactic acid production in the meat. It will decrease the pH value. This result might happen because of the post-slaughter handling of the carcass, which lead to usage of all glycogen in the meat. The lactic acid that was produced during the heat rigor was low. Next, the analysis of color. Chicken breast color depends on myoglobin, light scattering, and pH. Heat rigor lowers pH unless glycogen is depleted. At room temperature, drying and oxidation change color, while at 40 degrees Celsius, stable conditions minimize these effects and reduce enzymatic activity. Lastly, water holding capacity analysis. Heat trigger meat has lower water holding capacity due to rapid ATP loss, protein denaturation, and sarcomer shortening, leading to severe contraction and water loss. This causes greater drip loss, making it drier than control meat, where slow rigor mortis retains moisture. All of the information was concluded in the fourth content. To sum up, heat trigger meat loses more water and appears drier due to ATP depletion and protein breakdown. High temperatures affect pH and color, with controlled heat 40 degrees Celsius stabilizing color and reducing oxidation. Proper temperature management is key to preserving meat quality. In the fifth section, we will discuss about the quality solutions to tenderize the meat. For quality solutions, enzyme application helps to control the pH of the meat glycolytic enzyme and tender the meat proteolytic enzyme, which prevents the meat from becoming tough or too soft. Next, by applying electric current to the carcass after post-slaughter, it can make the meat become more tender. Lastly, using methods like needling, pounding, and thumbling can be used to break the muscle fibers in the meat, which also lead to more tender meat. The references that we used to provide the information will be shown in the last section. That's all from us. Thank you for watching.